the direct perfect linear relationship, because the majority of the points, if you just imagine there is a one line, majority points on the graph, right? Majority points on that particular line, but it doesn't give the more appropriate results, right? It based on your that line we are straight line which we are drawing here. So it doesn't give the more clear cut about the informations about the graph. Okay, so therefore somewhere this scatter diagram fails to give the more informations. So hence we will introduce the new concepts which is called as Pearson product moment correlations. It is called as a Pearson product moment correlations. So that is the next part, basically called as a Pearson's product moment correlation coefficient. It's very full name. Since this product moment correlation coefficient given by the Pearsons, that's why there is a name is that full name is their product moment Carl. But usually they say find Pearson correlation coefficient. You can skip this part, Pearson correlation coefficient, okay, or correlation coefficient. Simply they will say find out correlation coefficient. Okay, and this is used on basically when we talk about variable, two variables measured on, two variables measured on interval or ratio scale. So when you talk about the interval or ratio scale, I hope you are knowing what is the meaning of interval and the ratio scale. Okay, so when we have a data related to the interval and the ratio scale, I may go for always the Pearson product moment correlation coefficient. Okay. It is denoted by usually we give the notation small r. Okay, but you don't go by those notations. Just try to understand when we have a given the data of height and weight, then we are going to apply the Pearson coefficient. Okay, and then some notations will be given. Sometimes they write the correlation coefficient, sometimes they write the notations r, etc. So r is equal to covariance, COV means covariance xy upon standard deviation of x into, this is the into sign, into standard deviation of y. Okay, where you know what is COV, covariance between x and y is nothing but it's a covariance between x and y. And what is the formula? It is summation x minus x bar y minus y bar upon n, or it can be written summation xy upon n minus x bar y bar, and standard deviation of x can be square root of summation x minus x bar square upon n, or it can be summation x square upon n minus x bar square. Both formula, I think I have already explained how you can get this from this. Similarly, one can define for standard deviation of y. Okay. Now there are certain interpretations which is important in point of view, like to understand that point. Interpretation on R. So if I calculate the value of R, what should be their interpretation? Okay, so that's I wanted to know about that. What could be my interpretation value? So if my value of R lies between, let's start with a negative number. So this is the value of R. This is my conclusion. I will say conclusion. Okay. So if my value will be lies between 1 and minus 0.7. Okay. So what will be my conclusion? It's a strong inverse correlation. Similarly, when it is minus 0.7 and minus 0.3, then I will say it is moderate. What do we call? Moderate inverse correlation. If it is minus 0.3 and 0, then it's called weak inverse correlation. And if it is 0 and 0.3, then it is the weak. It's a weak direct correlation. Weak direct correlation. And if it is 0.3 and 0.7, then we call again moderate direct correlation, and 0.7 and 1 we called strong direct correlation. So this is the way you can go about the interpretation of the data. Like when you have given data and when you conclude the result, then you may go according to this value. Like you are not supposed to go according to your value. Okay, you're supposed to be use it this value, and you can go about this value. Any question? Any question? Let me know.
सर फिर से बताओ ना.
क्या बताना है? Tell me. What is the formula, or you wanted to understand this interpretation?
Formula, sir.
Okay. See the value of R. Its correlation, Pearson correlation denoted by R, which is the formula covariance, COV covariance between upon standard deviation of X into standard deviation. It is same. I think this is you have already seen in the paper 2 also, right? if I'm not wrong. Something you did in bivariate, correct?
Yes, sir.
Yeah, exactly same formula. Only thing is that
Yes, sir.
there you talk about the random variable. Here I'm talking about the data, actual data. That's only difference. Otherwise, the whole task is the same. Like there is no discrepancy. And then when you just do the problem, like it is the same standard deviation of x and standard deviation of y. This is remains same. Instead of x, we have a y. And this is the point which is very, very important. So my value will be lies between 0.7 to 1. You can say strong direct correlation. Strong direct correlation. If between this, then moderate direct correlation. If the between this, then weak direct correlation, okay, and so on. So this is the very, very important. Okay. Then there are several properties of that correlation coefficient. Okay. So let's see the properties one by one. Properties of correlation coefficient. Coefficient. The first property, the correlation coefficient. The correlation coefficient, that is can called R, lies between -1 and 1. If you just look at the above interpretation, just look at the above interpretation. From where to where? -1 to 1, right? This you have to prove. So how to prove? Maybe you are knowing this inequality, that summation x minus x bar, or I will just give the name of this first, whether you are knowing this name or not, I don't know. This is called as Cauchy. So using Cauchy Schwartz inequality, we have this relation. So Cauchy inequality says that whenever we have a two value summation AB, a whole square will be lesser than equal to summation A square into summation B square. This is called Cauchy inequality. So according to this result, one can write these expressions. Okay. The next line is equal to summation x minus x bar y minus y bar square upon summation x minus x bar squared into summation y minus y bar square will be lesser than equal to 1. Right? I have taken this, everything will be right hand side, left hand side. Right? Now, can I divide by n here? So next line, what I do, I simply copy this. Sorry. You can just divide by n here. Okay. So this is the whole square, right? This is the whole square. So this is the whole square. So I'm just dividing this by n side and keeping the whole square, right? That means actually I'm dividing by n square. So divide by n square means you have to always divide it in denominator also, right? So if I'm dividing in numerator, then I have to divide by denominator also, right? Now what is next? What is this part? Is that covariance? So it's a covariance between x, y, a whole square.
X, Y.
Yes. And this is, what is this? This is the variance of x into variance of y. I will use it short now. Variance of x into variance of y lesser than equal to 1. Or I can write here, or this can be right, standard deviation of x a whole square, right? Standard deviation of y the whole square. Because if I write standard deviation of the whole square, it becomes a square root, goes out, right? Look at here. What is standard deviation? With a root. If I square it, it's without root. But without root is what? Variance. So every in denominator and numerator we have a square. So is it not r square less than equal to 1? This implies what? Minus 1. Or I will just take here, like I will be say r lies between plus minus 1, implies that minus 1 less than r less than equal to 1. Hence proof.
Yes, sir.
So what I did here, I use this inequality I taken this right and left hand side. I divided by n square in numerator and denominator. This makes my covariance. In denominator, we have like I can write it this in terms of notations. That is sg of x ka whole square, sg of y ka whole square. Since everywhere we have a square, I can write r square and less than equal to 1, and then further I can, and hence I can prove it. Correct? Hence the first property have been proved.
Yes, sir.
Any question in the first property?
No, sir.
Let's go ahead. Let's go ahead with the next property. What's the next property says? So the next property will be, that is a part, you can say B part. The correlation coefficient, sorry, is not affected by shift of origin and change
Chart.
in scale. And such, so this type property we have seen for standard deviation, if you remember. Something like that we have seen in standard deviation. So if I have X data and if I have Y data, okay, and if I'm trying to obtain the correlation, let's say which is coming 0.5, okay, and now I'm changing my X to X minus 3 by 2 and Y to X minus 5 by 2. And if I'm trying to obtain the correlation R, which turns out to be 0.5 only. So this means that the correlation coefficient is not affected by shift of origin. Shift of origin means if I'm X is changed by X minus 3. So I have shift their origin. मतलब X से मैंने X minus 3 में shift किया and change in scale and X to X by 2. Okay, so this is my scale, this is my origin. So if I'm doing this to this transformation or this to this transformation, my correlation, which is R, is not going to be effect because this is the one result, right? This is one result, and one can prove this also. One can prove this also. Okay, so let's prove. Let's see how to prove. Let U is equal to X minus A by C. So I have X data, okay, and I have changed to X minus 3 upon 2. So let's assume this is U. So U is equal to this, and similarly V is equal to Y minus B upon, let's say, D. Okay. Now based on these, what could be your X? X become, what could be X? U into C and plus A. So A plus CU. And what could be your Y? It will be B plus
BB plus Y.
D.
BB.
Correct. Now can you calculate X bar from here? X bar. What could be your X bar?
X bar is equals to A plus C bar U.
Correct. So X bar is equal to summation of X upon N as according to usual definition. Correct. So this is equal to what? Summation A plus CU upon N. if you look at summation of constant, you remember what is summation of constant? NA, right? NA. When you repeating that constant will be n time, it's going to be NA, correct? It's going to be NA plus C times summation of U upon N. This is going to be what? It's going to be A plus C times U bar, because U upon N is going to be U upon N is going to be U bar according to the definition.
Yes, sir.
This is going to be U. Similarly, can I write Y bar is equal to this quantity? So Y bar is equal to what now according to this result? B
D
plus,
plus BV bar.
absolutely right. Now, what actually I'm doing? What I'm trying to obtaining? What I'm trying to obtaining? I am trying to obtaining the correlation between U and V. क्या निकालना है मुझे? Correlation between U and V. So I know the formula. Correlation between U and V के लिए what I wanted to calculate. So I need to calculate x minus x bar. So what could be x minus x bar now? This is my x, this is my x bar. If I subtract, what I get it? A get cancelled. And what is left here? Cu minus U bar. So can I get C times U minus U bar? Similarly, Y minus Y bar. What we will get it here? Y minus Y bar. BB get cancelled. D times B minus B bar. Hence, what is the covariance of x and y? Which is summation x minus x bar, y minus y bar on n. Now, what is summation x minus x bar, y minus y bar? You have already calculated. You can substitute here. So, क्या मिलेगा? C time. Can you look at here? Summation. This quantity you have, right? You can use summation. Substitute this quantity will be here. U minus U bar. And what about D? D time V minus V bar. Whole upon n. This is equal to what now? You can pull out C and D out. C and D summation U minus U bar V minus V bar. Whole upon n. But what is this actually? This is what? This is the covariance between U and V. So what we obtain? Covariance between x and y is nothing but CD time covariance between U and V. Correct? Now, what could be standard deviation of x according to formula? It is summation x minus x bar square upon n according to formula. Now, what is your summation x minus x bar? We have already obtained. What is that? C time U minus U bar. So if you just square it this, it's going to be what? Summation C time U minus U bar a whole square upon n. So when you just open it this, what is going to be happen? What is that? This is going to be, oh, just a minute. Is equal to C. This is C square. When I pull out, it's become C. Square root of summation U minus U bar square upon n. But what is this? C time standard deviation of U. So standard deviation of x become this. Similarly, standard deviation of y is going to be d times standard deviation of v. Hence r x y means original correlation. What is the formula? Covariance between x and y upon standard deviation of x into standard deviation. Do you have covariance? What is the covariance? CD into covariance of u and v upon what is standard deviation of x? C times standard deviation. What is covariance of y? D times standard deviation. And you look at here, this is equal to what? What is left? This is the
Sir,
correlation between. So what we found? When you do shift of origin and change in the state, my correlation between new variable is not affected at all. Okay. This is the one way they are saying. Other thing they were saying, the correlation coefficient is independent of shift of origin and scale. So the both result you can understand. Okay. You can always remember both the result can be quite useful. Okay. So you may don't stick with uh, one step.
नेगेटिव दोनों है.
Yes. तो कुछ भी मेरा होने दो, मेरा डेटा कुछ भी होने दो, if I'm interested to get the correlation, my correlation will be not affected even if I shift off, do whatever number. Okay. So that is the you can make note of that. Now let's take the data. Let's take some data, raw data, and try to get some what is that? Try to find out some correlation. Let's see whether we can able to do it or not. So example number 1 is already done. Let's take the example number 2. So this is a one property, and other property that correlation coefficient is a pure number. It's a pure number. Okay. Therefore, it is independent of unit of measurements of the variable. So it has no unit. It is unitless. Correlation coefficient is the unitless. So third property you can write.
Yes, sir.
Yeah. C will be the correlation coefficient is a pure number and it is independent of unit of
Masak, 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 masak.
measurement of.
Aja. Kala. तू भी
Gopi, mute yourself. Gopi, yes, Karma, mute yourself. So this is my third property of correlation. So let's go to the example number 2. Suppose I consider some raw data, roughly raw data, not actual number. Or I will just take that. Let me see whether I have some data with me. I need a small data, which is like quite useful. Let's take down X data and Y data. Okay. Let's say 20, 30, 20, 40. So this is going to be almost 50, 50, 100. Let's take 40. This is 40, 40. And this is somewhere 10, 20, 30, 60, 20, 20. Okay, this is my data, and I'm interested to obtain R and comment on it. Solution. So what we have to do in such an example, you need to create a table like this. Okay. So first contain X, then you have a Y, then you can calculate X square or X minus X bar. See, it depends on the problem, which which data, which formula you are using, which formula you are using. So if you are using this formula, like this one, so how many columns you have to create? It will be X minus X bar, Y minus Y bar, and then multiplication of that. 3 हो गया. Then standard deviation of X के लिए, so 1, standard deviation of Y के लिए 2. So total 5 columns you have to create for this data. Like if you are using this formula. But if you are using for this formula, summation XY wala, then you have already XY, you have already X and Y. You need to simply uh, just a minute. So you need to simply create 3 more column to the program, and it is just take down X here, just take down Y here, and calculate X square, calculate Y square, and calculate X and Y. So 20, 30, 20, 40, 40, and here we have a total. So थोड़ा सा इसको मैं shift करता हूँ, so that total will be get adjusted there. So this will be shifted a little bit up, so that I'll do something for this. Okay, and here we have a total, because we need total because we want addition. And here we have a 10, 20, 30, 20, 20. So just do the addition of this all and let me know what could be the addition. Similarly, you can calculate x square, which is 400, 900, 400, 1600, 1600. Similarly, y square, 100, 400, 900,
100, 400,
400, and
400.
x into y. So this is 200, 600, 600, 800, 800. So I think this is 150.
Yes, sir. X.
What about y? 100.
100.
100.
Yeah. What about x square?
4900.
4900. What about y square?
2200. 2200.
1200. What about x into y?
3000.
3000.
Now, once I have calculated this all data, I need to use it my formula. Like I need to compute. I need to use the R formula. R is equal to what? So covariance x and y upon standard deviation of x into the standard deviation. What is the formula? It is summation xy upon n minus x bar y. So if you want, you can calculate x bar here. What is your x bar? 150 divided by n. What is your n? N is 5. N is 5. So x bar upon this is going to be how much? 30. What is your y bar? This upon 5, right? 20. Into summation of x square upon n minus x bar square into summation y square upon n minus y bar.
Y bar square.
Yeah. So you can substitute these values. So this is equal to what? This is, sorry, the root will not come here. Root will not come.
सर रूट आप लगाए हमें तो
Yeah, this root goes away.
दो रूट थोड़ी लगता है एक जगह पे.
So this is going to be 3000. This is 3000 upon 5 minus 30 into 20. Whole thing divided by 4900 upon 5 minus 30 square and 2200 upon 5 minus 20 square. So how much it is? 600 minus
600.
600. Now this could be whatever answer. I will get answer will be 0.
0.
Just do this calculation and let me know what is right. Since your numerator itself coming 0, your numerator itself coming 0, right? So denominator could be whatever values. It doesn't matter for me. It will get some value. You can calculate some get value, some get value, but 0 upon something is always 0, right? So can you just tell me this value? What could be this value? Anyone calculate it? What could be the standard deviation of that part?
56.585685.
Sorry,
56.5685.
total multiplication, total answer, or
Yes sir. नीचे का sir.
56 point कितना?
56.5685.
5685. So you may get this answer, but final answer is going to be 0 only. So you get R ka value will be this much. So what it shows, there is no relationship between X and Y. Means there is no relation exists between X and Y. So you can take down. Therefore, though there is no relation exist between, no correlation exists between X and Y. Now suppose you have given direct data like this. Okay, can find R based on given data and comment on R, and also comment on value of R. Just calculate and let me know what would be the answer. So this is the one example. You can try out another. See, there are several examples. Okay, so I'm just listing few. I'm just listing the few one, but you can work out like several examples. Refer it, like you can go about the different textbook or notebook. Just try to find out. You can just solve it and tell me that value. Even R is 0.5, covariance between X and Y is 4, standard deviation of X is 2.5, summation of Y square is equal to 192.4, N is 10. So can you calculate mean of Y bar? Calculate Y bar. I hope some have given the answers. Yeah, Sivam Pandey is saying absolutely correct. But Sivam Pandey, you have a lot of questions. I'm going to post the practical only in your GC. Okay. So very soon you will be get the mail. Okay, regarding the invitation. So you can join. You can connect that GC, and once you get GC, these materials and the practicals, which we are going to do this on based on the correlations, you can do so many problems based on that. So I'm just giving like at least 5 questions based on each topics, so that you will be have a practice on like every topic. It's not like just teaching theory and then practical you can do it by no. So teaching, the aim of the teaching theory will be very important here, and then practical part will be like supposed to be done by you only, supposed to be done. Okay. So if you all can able to do that practicals by own, so that session we can use it for the lecture time. So that we will see. I'm going to upload it that very soon practicals. So you can, so you may get some of example from here, some of example by new examples. Okay. So you can work on that. But at least you can try out like few this example, 1 2 examples. Okay. Any question so far? Anyone? Tell me. So no question. So no problem. Okay. So you keep on practicing. Keep on practicing these type of examples.
Yes, sir.
Okay. And I think you are already knowing which are the dates we have a lecture. So today we have a 2 class, and then tomorrow Thursday we have a 1 class around 1 o'clock, and then Friday we have a 2 o'clock. Correct?
Yes, sir.
Yeah. So make the note of that, and then according to that schedule we can conduct our lectures. अभी किसका lecture है? Next lecture?
Physics.
Physics. Okay. So madam will join here only, right?
Yes, sir.
Okay. So we'll wait for a moment. And the madam will join, then we can start.